if we take a look, um, we've got on here, we've got, let me pull this over here. There you. We've got right here these oxygen ones. So if we have an alcohol, I'm sorry, if we have a carbon chain, and that's all this R means, is it's a number of carbons attached to an OH, that is what we call an alcohol. So if it is CH3 attached to an OH, we know that that would normally be just methane right there. We drop, for the IUPAC system, we drop the E from methane and we add OL. That is methanol. If we take a look, here we have CH3, CH2, OH. That would be ethane without that there. We will call that ethanol. Easy enough. Here we have an oxygen between two chains. So let's say if we had CH3O, CH3, that will be what we call, there's a common name, but we don't want to use the common names. That would be what we call either dimethyl ether is the common name, or what we can call meth oxy. So basically you just look at what's attached to the O, and it's the shortest chain. Meth oxy methane. So if this had a CH2 and a CH3 here, it would still be methoxy because this is the shortest chain. But instead of being methane, it would be methoxy ethane.
So we basically break it up into two different groups.
Two different chains, yep. Methoxy ethane. And the one, the methoxy one, that's the one with the shortest number. It's the smallest chain. Right? This is still our parent chain. Yeah. So there are two, those are basically the oxygens being within the chain or whatnot. This one is within the chain between two carbon groups. This one is at the end of the chain with a hydrogen added onto it. This could also be somewhere in the middle of the chain where you would have it coming off of, let's say, right here. And that would just be CH then. So this would be a 2, because that's where it is. 2 propanol. What type of hybridization does this C right here have?
sp3.
sp3, right? 1, 2, 3, 4. sp3 hybridization. What type of hybridization does this oxygen right here have? Or this oxygen right here?
sp3.
sp3. Don't forget that even though we don't write them on there, it does have those other pairs of, right? Yep, it has those lone pairs on it. So remember, hybridization as determined by looking at the high electron density location. So 1, 2, but then there's 3 and 4. All right, a double bonded oxygen at the end of a chain, or in reality at the beginning of a chain, it's called an aldehyde. Formaldehyde, CH2O, that is formaldehyde common name, but we call it methanol for the IUPAC. This would be ethanol. This would be propanol. Nope, that should only be CH on there. Sorry about that. Propanol. What's that? Yep, the one that it is right now is propanol. Yep. Ethanol would have a CH here also. For some reason, I wasn't thinking, and I had CH2 there. Yeah, Brody.
So since the double bond's always gonna be like on the first atoms, do you not have to number it?
You got it. But if we did have to number this, then this would be the number 1 carbon. Like, let's say we had something coming off the chain right here. That would be 2-methyl propanol.
So you would say 2-methyl 1-propanol, basically?
That would also be acceptable. Yep.
Okay.
Again, you don't have to put the 1 for the propanol because it's going to be on the 1, but you could. Nobody would sit there and go. Blah blah blah. Hybridization of this carbon.
sp2.
Right, sp2. High density locations are 3 of them, 1, 2, and 3. This counts as 1 high density location. So you only have sp2 hybridization there. Now, this is an aldehyde, but you can have a double bond on different carbons, but you don't call it an aldehyde then. For example, imagine if we had a CH3 right here. So the double bonded is on which carbon? 1, 2, 3, or 1, 2. 2. So this would be 2. It is no longer an aldehyde. It is a ketone. All you do is 1, 2, 3, 4. So it's 2 butane. We take the E off and we put 1 there. And it's pronounced as 2-butanone.
So is aldehydes like the O is at the end, while ketones, the O is in the middle?
You got it. Aldehyde is a double bonded O at the end, and a ketone is a double bonded O at the middle. So if it says ketone, you're definitely going to have a number there, right? Let's try a few before we go on to the other ones. I think we did this one yesterday too. Pentanol. So what's the main chain number?
5.
5. 1, 2, 3, 4, 5. 2. We have an OH coming off. Decanol. How many?
10.
10. It says 1 decanol. So we put the OH right there at the beginning. We also have 2 bromo. So I'm going to go ahead and get that real quick. And 4, 4-dimethyl. 1, 2, 3, 4. 4, 4-dimethyl. Now I got to get these chloros. So 1 chloro. 1, 2, 3 chloro. 4, 5, 6 chloro. 7 chloro. Is this showing cis or trans representation? This is for the student of the month question right now.
Can you even do cis and trans since there's no double bond?
Yeah, right? That's the trick. Even though we've got some stuff on the same side and some stuff on opposite sides, this is not a problem where you would even talk about cis and trans, because you only talk about cis and trans when you don't have any movement around the bonds. If we take a look, remember, if everything's single bonds, everything can sit there and rotate freely. Only when you have the double bond is stuff stuck. So we would not even bother with cis and trans on these type of things because they don't have double bonds. Heptanal. 1, 2, 3, 4, 5, 6, 7. Al, well, they didn't tell us where to put it. Why is that? It's always on the first one if it's an aldehyde, right? Boom. Hybridization for it. sp2.
sp2.
sp2. Three areas where electrons are. 1, 2, and then the hydrogen. Would be the third. How about for the oxygen? What's the hybridization for the oxygen there? sp2, right? We have one bond, one area for bonding electrons, and then we have the 2 lone pairs, which are also areas of high density for electrons. 2-ethyl-3-methyl-hexanol. 1, 2, 3, 4, 5, 6. Hexanol. We've got that done. 1, 2, 3. La 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 la. Hybridization for this carbon right here. sp3. How many hydrogens are attached to it? 2. What is the name of its little brother? Good. All right, hexanone. Can we do hexanone? I told you ketones. It's 3 hexanone. So that means 1, 2, 3, 4, 5, 6. Where's the double bonded O?
3.
3. Boom. 1, 2, chloro. 2, 4, dimethyl. 1, 2, 3, 4. Boom. What's the hybridization of this carbon right? Cha.
sp3.
sp3. How many hydrogens are bonded to it?
0.
0. What is the name of its little brother? That's right. We got it in class. It was Eric. Nice try though. All right.
Wait.
Butanoic acid. No, we're just spinning around. Butanoic acid. All of these noics. Can't do those. Can we do this one though? How many carbons here? Looks like 1, but it's weird. I think there's 1, 2, right? So this has 2 carbons on each side. I'll go ahead and draw them in because this is weird notation. I get it. So if we take a look there, we have ethyls on each side. So you could call this diethyl ether. That would be the common name. Otherwise, we should call it F-oxy. Because we look at the smallest side. In this case, both of them are the smallest side. Ethoxyethane. Oh, we can do this one too. 1, 2, 3, 4, 5. Again, I apologize for the weird way that that is written. 1, 2, 3, 4, 5 is what? Pent, but it's a ketone. So it's pentanone.
Pentanone.
Good. And where is the ketone? Is it on the,
On
one,
the second.
the second or the 4? It is on the second. 2-pentanol. Lolly, lolly, lolly. All right, carboxylic acids. I'm sure that they showed you these in biology last year, right? You guys probably did the lab where you like put peanuts on like a garbage bag and you can see through it. like a McDonald's bag or whatever, you know, when the grease gets through it. That's like a test for fat. Then you probably took droplets of iodine and put it on a cracker and it turns black, goes from brown to black, right? Were we already in quarantine at that? Oh. Ouch. Who did you have? Who was it? You're a skaglet? I didn't think you were a skaglet. Yeah, he is nice. So if we take a look, I got my Valentine's gift for him already. I'll let him tell you if he wants to. But not yet, Monday. So if we take a look, we always get each other gifts and stuff. I got him a bidet. You know what that is? Yeah. Because I had a bidet for like 6 or 7 years or whatnot, and then we went out camping, him and I, for Panther Quest once, and I just mentioned it casually, and he's like, "Whatever, you don't have a bidet, you're crazy." So I don't know if you guys know much about Panther Quest, but we have like all the teachers and the people get together for a little kind of picnic thing at the end of it all, because it's like a lot of work. I was like, "Whatever, you don't have a bidet," and I gave it to him, and like, it's so funny. No, it just fits on the toilet. Yep. Yeah, here you go. Here's the bidet. Yeah, and it's funny. Then I got his child for the baby shower. I got him one of those things where you dispose of all your diapers. Basically, I'm taking care of Mr. Skaggs' bathroom. Yeah, right. Keeping him up on that. Basically, it shoots water up on your butt, on your bum to clean it. Yeah. Well, if you had poop on your arm, would you just wipe it off with paper towel? Right? Is it weird? I don't know. But if you did. All right. Sorry, hum viewers. Let's continue. Carboxylic acids. We got off track there, but somebody probably talked to you about these in biology class. So if we take a look, the OH is part of the carboxyl group. So you have this double bonded O, which then you have this carbonyl carbon with one OH attached to it. So again, this always goes where? At one of the ends, right? So the double bonded O, which is an aldehyde, and now you have an alcohol at the end, right? So an aldehyde and an alcohol together make a carboxylic acid. Dun, 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 dun. So let's take a look. Whenever you have a carboxylic acid, you take the N, the E off, and you put oic on there. So this is butanoic acid. Well, we know butanoic as but having 4. So on the end here, this will have a double bonded O, and coming off of this, we will have an OH. So 1, 2, 3, 4 for the butan. This oic part is the O and the OH. This is an acid because it will be able to relieve the self of this hydrogen and put that into solution, which would bring the hydrogen ion concentration up, which is what an acid does. Yeah. All right, now here's where things get silly. Pentanedioic acid. What? Well, you can break it down. Pentan, this is like somebody just trying to like see what they can get you to be able to show you what you can actually do if you break things down. Pentane means 5. Dioic. Well, that means that we're going to have not only on the 1, we're going to have a carboxylic acid on both ends. Right. What is the hybridization of this carbon right now?
sp2.
sp2 is correct. This oxygen,
sp3.
sp3 has the two lone pairs. And this oxygen, I asked about the carbon. sp2, right? So the carbon has sp2, this oxygen has sp2, this oxygen has sp3. How many hydrogens does this carbon have? Two, right? I'm sorry. So the thing about this test is, if I want to make it all multiple choice, I can't have you do drawing, so I can only ask you about the drawing, right? But I don't know. I haven't made the test. I have like a little bit more than a week to make it, and I've got those times on those I-step days, so we will see what becomes of the test. The problem is that next weekend is a 4-day weekend. I don't want to grade a bunch of hands, you know what I mean? Like, but you have all that time. Yeah, right. How about this thing? It just looks big. All we got to do is break it down. Hexanoic, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. It says 2-methyl. I'm going to go ahead and put the methyl on there, and then I'm going to put the double bonded O and then the OH here. So there's my hexanoic. There's my 2-methyl hexanoic. Now I need 4,4,5 triiodol. Iodol. Iodio. 4,4,5 triiodiol. Tri means that we will have 3. 1, 2, 3, 4. No, there's a carbon right there. 1, 2, 3, 4, and 5. Bada bing, bada boom. How about this guy? I know, again, silly. You have to ask yourself, how many carbons are there?
3 carbons.
3. It's so silly, right? 1, 2, 3. 1, 2, 3. So 3 is prop. We would normally call this propane, but we drop the E and we change the ending to propanoic acid. Propanoic acid. Yeah. Okay. Hold on, let me prepare myself. All right, go ahead. Yeah, soda stream. Mm-hmm. Yep. That's actually 2 units from now. So we'll get to the soda stream 2 units from now. What is it? Is it not called soda stream? No, it is. Yeah, yeah, the soda stream unit. Yeah, we do a whole unit on it. Amazing. All right, last one. Is this a propanoic acid? I mean, is this a carboxylic acid?
No.
No. This has a double bonded O and an O, but that O is not an OH. This has a double bonded O, which is like a ketone, and it has an ether, right? So this is known as an ester. You have ether and you have ester. An ester is an ether with a ketone. Ketone. Right? So here, if this weren't there, then you would have an ether. If we put that ketone on there, this whole thing becomes an ester. Does that make sense? Yeah, right? Cool. So the way we name this one is we take the smallest Actually, I'm sorry. That's the way we name an ether. The way we name this one is we take this and we look at this as its own little thing. So how many carbons are attached to this oxygen? One.
One.
Yeah. So we would call this with a substituent name like methyl. Because there's one carbon attached to this. And what do we have here? 1 and 2. So this part would be considered our parent chain. So that would be considered ethane. But when you're naming an ester, you change the E to an O8. Ethanoate. Methylethanoate. What's that? Yeah, right. Because L's are hard to say sometimes, right? Like if you have a list. Right? So if we take a look, if I add another carbon there, what changes? Does the methyl change or the ethanoate change?
The ethanoate chain.
And then what does ethanoate become?
Propanoate.
You right? Oh my gosh. Yeah, propanoate is correct. So this would be propanoate. Now if I change this, what would we call this now? Right. Yeah, it's like a hippopotamus, right? Hippopotamus. Propylpropanoate.
Wait, what happens if the a chain attached to the single bonded O is like 4 carbons?
That's the thing. That's why I did this. I can't believe you've done this. If we do that, then what?
Well, wouldn't the smallest chain now be the propyl?
That's you're falling into what I said at the beginning, right? And remember, I corrected myself. We only worry about the smallest chain whenever we're looking at ethers.
Oh, so for this one, we only look at what chain's attached to the single bonded O, and that goes in front.
Yeah, you got
Okay.
it.
Thank you.
You're welcome. So what are we gonna call this? Propyl butanoate, right? Propyl.
Wouldn't it be butyl propanoate?
Oh, I'm sorry, butyl propanoate. Yep. Good call. Butyl propanoate. Yep. Butyl propanoate. Propanoate. Boom. So that's what I got for today. Questions out there? Home viewers. Remember to get your pet spayed or neutered to control the pet population. It's something Bob Barker used to say at the end of Price is Right. Every day. You are. Come back to us. I don't know. We are all done here. If you guys have questions, you're more than welcome to stay on. Otherwise, get out of here. I'm going to put a review sheet on there, so there's no homework tonight, unless you have parts of this packet that you've not done. I'm going to put a review sheet on there, hopefully by the end of this period or next period. But it will definitely be on there before tomorrow. If you don't want to meet tomorrow because you don't have questions, it is a optional Zoom. It's basically going to be a review day. So if you want, you can skip and then you can work on that project, get it done before even next week, and then you don't have to worry about it all next week. You guys might have an easy next week because you're sophomores. Just remember that when you're juniors and you're taking that ISTEP.